Next, NASA says its Voyager 1 probe, the most distant human-made object in the universe,
in the humid quiet of a June morning, amid fields heavy with the promise of summer, something unseen is moving deep beneath America's central plains. Far above the crops and quiet rivers, a network of NASA satellites circles, patient and tireless, their sensors sweeping across the slow pulse of the continent below. From orbit, Earth reveals itself not as a simple patchwork of farms and towns, but as a shifting mosaic of energies and invisible currents. On most days, these satellites record the familiar, seasons turning, clouds drifting, the land's timeless calm. But this June, below the endless blue of the central United States, a new kind of data accumulates. Readouts flicker, subtle shifts in surface elevation, odd electromagnetic signatures, unaccounted for pulses barely rippling beneath the skin of the land. At first, the signals are dismissed, meaningless static, a stray disturbance in the background, mere artifacts in the radio spectrum. Yet as days pass, the evidence aligns. A pattern emerges, suggesting that something large and mysterious may be in motion beneath the familiar heart of America. NASA scientists are practiced in caution and compelled by curiosity. Stories reach their desks. Reports of a decades-old satellite, long dormant, unexpectedly sending out a powerful radio signal. Updates about a growing magnetic anomaly in the South Atlantic, where Earth's shield thins and fractures. The sudden uptick of high-energy particles stirring in low Earth orbit, persistent and unexplained. Now, the central U.S., so removed from the violent dramas of tectonic collision or volcanic upheaval, has become a puzzle, its soil marked by signals no one yet understands. The satellites hover on, their precise instruments cataloging each new anomaly, each ripple in the electric quiet. What silent force moves unseen underground? What has drawn the attention of NASA's vigilant eyes to this tranquil center of the nation? And, most unsettling of all, how might life be altered when the continent's calm is broken by a signal with no immediate explanation? Satellites and signals, when the ordinary turns ominous. At dawn's edge, before birds stir, NASA's satellites resume their silent observations. Their electronics, hardened against the harshness of space, measure the surface temperatures of fields, the moisture levels that sustain crops, even the slight undulations in the ancient course of the Mississippi. But this June, instead of ordinary readings, monitors at NASA's centers register something else, a thread of strangeness running through the data, subtle ground movement, irregular lines of stress, electromagnetic echoes pulsing across the landscape, each without a clear source. These satellites are built to register the imperceptible. Some detect minute shifts in elevation, measured in millimeters. Others, equipped for magnetometry, scan for the tiniest tug in Earth's fluctuating magnetic field. Specialized instruments eavesdrop on the planet's quiet conversation with space, parsing the faintest signals in radio and microwave bands. Anomalies are typically fleeting, static from thunderstorms, blips from solar flares, stray noise from cosmic events. But in June, the central U.S. anomaly grows. What begins as a localized distortion near Oklahoma broadens, seeping into Kansas and creeping toward the river valleys of Illinois and Arkansas. Satellites map heat emanations with no fire at their source, slight deformations in the surface, and an electromagnetic pulse waxing and waning with odd regularity. In mission control, scientists work to explain the data. Algorithms meant to filter out noise now struggle. This pattern refuses to be dismissed. The electromagnetic undertone of the continent has shifted. Beneath the crust, something stirs. Is it geology, a dormant fault line rousing, or perhaps something more complex and not yet cataloged by Earth science? Underlying many analyses is the phenomenon known as the South Atlantic Anomaly, a well-documented region above the Southern Atlantic, where Earth's magnetic field dips especially low. There, high-energy particles slip past the weakened shield, interfering with satellites and sowing electronic chaos. But the disturbance detected over the central U.S. is not a simple mirror, but a new development, a phenomenon with its own unique signature. Memory and machinery, Relay 2's awakening. As June's changes unsettle the central U.S., an even stranger event unfolds far above. On June 13th, engineers at NASA's Deep Space Listening Posts register a startling signal. A clear, powerful radio burst emanating from Relay 2, a satellite decommissioned and silent since 1967. Once a symbol of early spaceflight, Relay 2 should have remained inactive, one of countless relics orbiting in silence. The burst is unmistakable, an organized high-energy transmission. At first, engineers consider a glitch, perhaps a cosmic ray jostled an ancient circuit, but the signal is too strong and consistent to be coincidence, provoking new question. What woke Relay 2 after nearly 60 years of quiet? Some point to increased activity in low Earth orbit. Satellites encountering the South Atlantic Anomaly routinely suffer from single-event upsets, glitches induced as cosmic rays overwhelm their protections. Could a similar anomaly, spreading or intensifying, have jump-started Relay 2's ancient circuits? While this link is speculative, the coincidence draws attention. If the increased presence of high-energy particles, known to disrupt modern satellites, can cause unpredictable behavior in old systems, there is concern for equipment thought secure. Scientific alerts reference a massive anomaly spreading across Earth, with suspected ties to forces deep underground. Suddenly, the impossible, a dead satellite speaking again. Engineers study the records, looking for shared causes. The thread connecting Relay 2's revival and the central U.S. disturbance may be tenuous, but both seem to coincide with a period of heightened geomagnetic and energetic instability. Magnetic fault lines, the growing anomaly. The Earth's crust is a living record, etched with scars of shifting plates and the faint trace of unseen forces. One of the most enigmatic of these forces is the South Atlantic Anomaly, a region above South America and the South Atlantic, where Earth's magnetic field thins, exposing satellites to intensified cosmic radiation. For decades, engineers have steered cautiously through this zone, where electronics falter and data becomes corrupted. But in June 2025, new satellite data paints a troubling picture. The SAA may no longer be a confined anomaly. Its edges appear to be stretching and fragmenting, spilling magnetic weakness into previously unaffected regions. NASA's updated magnetic field models show disturbing trends, zones of depletion migrating northward and inland, pressing towards central continents. What was once a localized threat now hints at global implications. Subtle electromagnetic fluctuations ripple beyond the South Atlantic. GPS signals flicker, radio waves distort, and communication blackouts are reported sporadically far from traditional boundaries. Though minor in isolation, these disturbances are stacking up, suggesting the Earth's magnetosphere is becoming less stable, less predictable. From southern Africa to the central United States, technicians and observers alike are noting irregularities, unexpected satellite resets, curious radio echoes, and, in the most mysterious reports, brief auroral glows appearing well outside their usual polar ranges. Though rare and unverified, the rumors deepen the mystery. In a world increasingly dependent on satellites, global positioning, and uninterrupted digital flow, this silent shift matters. The question now isn't whether the anomaly is growing, but whether humanity is prepared for a world where Earth's invisible defenses are evolving in ways we cannot yet predict. When the map shifts, reading hidden faults and deep currents. To understand Earth's interior is to accept uncertainty. Satellites now record subtle ground deformation, atmospheric warming, and odd fluctuations in the electromagnetic spectrum, over the central U.S., evidence of a process at work, even as its source remains elusive. Geologists explain that Earth's crust is rarely as stable as it appears. The American Midwest, for all its apparent calm, bears the scars of long-extinct mountains and rivers, its bedrock crisscrossed with faults, most inactive, but not beyond reawakening. While modern seismic instruments have not detected significant earthquakes in the region this June, NASA's satellite data on ground movement and surface heat is compelling. One leading hypothesis is that stresses long buried are now surfacing, perhaps as the planet's crust readjusts or as deep-seated heat migrates upward. Alternatively, fluctuations in Earth's magnetic field might be causing electrical currents in the ground, a phenomenon known as geomagnetically induced current, which can subtly affect both geology and technology. The union of these processes, mechanical shifts in the crust and electromagnetic change in the atmosphere, might explain the strange signals. Measurements indicate not just surface tremors or temperature changes, but irregularities in the electrical environment, potentially connecting the deep Earth to the zone where satellites orbit. And yet, no conclusive evidence ties ground movement and electromagnetic anomalies together. The pattern is new, and its causes remain under investigation. Across the universe, patterns resonating beyond Earth. NASA's purview extends to the solar system and beyond. Patterns captured in distant worlds often offer perspective on challenges at home. This June, several striking discoveries arrived nearly at once. A Mars Odyssey orbiter sends back images of a vast, previously unseen formation breaking through early morning cloud cover, an event that prompts speculation about geological upheaval on our neighboring planet. While there is no clear connection between Martian geology and terrestrial anomalies, the timing prompts reflection on the dynamic processes that shape all planetary bodies. Elsewhere, astronomers register bright radio pulses accompanied by X-rays, their source 15,000 light-years away, an object whose energetic outbursts light up sensors meant for Earth and solar observation. These cosmic events, distant as they are, act as reminders that powerful forces work throughout the galaxy and sometimes echo in Earth's environment. Meanwhile, Venus dominates the pre-dawn sky, rising bright and unwavering as a visible symbol of the broader planetary context, unaffected by Earth's current tremors, but a constant reminder of how planets are shaped by both slow and sudden forces. NASA also warns of a new threat, an asteroid approximately 200 feet in diameter, now slightly more likely to collide with the Moon, underscoring the randomness and interconnectedness of cosmic motion. These events do not offer cause and effect, but together they highlight the universality of change. Earth's anomaly is not unique in a universe of restless planets and shifting fields. The parallels, with Martian formations, cosmic radio waves, and asteroid warnings, remind us that dramatic shifts are commonplace in the solar system. On the brink, machines at risk, people unaware. For most Americans, the anomaly is felt only as rumor, a static-filled radio, a dropped call, a fleeting sense of unease before a storm. Day-to-day life carries on. Farmers tend to their fields. Cities bustle as usual. Satellite operators, emergency planners, concern mounts. Satellites traversing the zone of increasing anomaly, especially those in low Earth orbit, face heightened risk. Single event upsets, induced by high-energy particles, a well-known hazard in the SAA, now become more likely elsewhere. Slight but persistent problems emerge in communication networks, data errors, GPS glitches, lost signals without an obvious cause. While not catastrophic, these issues accumulate, prompting new strategies to maintain network stability. NASA and affiliated organizations issue advisories. Aerospace companies replan the routes of satellites, seeking to avoid regions where the anomaly's effects are strongest. Emergency planners in Midwest cities prepare for possible outages. a prudent response to risk, although there is no indication of imminent disaster. The anomaly remains a scientific and technical challenge, not, yet, a crisis for daily life. The Relay 2 incident is taken seriously. If an ancient, dormant satellite can be awakened by unusual environmental conditions, even newer infrastructure may be more vulnerable than expected. This lesson prompts vigilance rather than panic, a renewed urge to monitor, analyze, and safeguard. A wariness grows. Science, speculation, and the unknown. NASA's traditions include humility before the unknown. For every anomaly resolved, others arise. The current pattern, magnetic field changes, satellite disruptions, subtle ground movement, resists easy summary. Scientists debate, is this a prelude to long-term magnetic instability, a rare but natural fluctuation, or simply an episode soon to fade? Some urge caution, pointing out that Earth's magnetic field has shifted and changed many times over millennia. The SAA itself has grown, split, and changed before. However, the rapid evolution of the current anomaly and its encroachment into areas never before affected tests these reassurances. Amateur radio operators log bursts of unexplained static. Farmers recount odd compass behavior at dawn. While most reports remain anecdotal, they add detail to the overall sense of instability, fuel for curiosity as well as anxiety. Through all this, scientists work to refine their understanding. Satellites are repositioned, new missions are considered. The anomaly, its origin uncertain, its trajectory unclear, becomes a focus for renewed collaboration and discovery. Living with uncertainty, the fragility beneath everyday calm. As June unfolds, the land appears untroubled, grass sways, rivers wind their courses, life continues much as before. Yet both above and below the surface, the tension persists, a silent reminder that change can be hidden, gradual, waiting to reveal itself in unexpected ways. For most, the presence of NASA's satellites and the vigilance of scientists provides reassurance. The anomalies detected are real, but have not led to calamity. Their importance lies as much in what they teach as in the disruptions they cause. The new data, persistent and compelling, challenge old assumptions and invite new investigations. Is this a sign of greater changes to come, or simply a fleeting episode, a season of instability in a planet marked by constant flux? Satellites remain our witnesses, reading magnetic pulses and ground tremors, alerting us not only to crisis, but also to the silent processes that slowly shape our world. Their observations underscore a lesson as old as science itself. The planet is always changing, and our awareness is what lets us adapt. In the dusk, as the air cools and night settles in, the anomaly's question lingers, unfinished but insistently real. What quiet shift, what unseen currents now shape the world? And what stories will the next season's data reveal? If you, like us, are drawn to this unfolding mystery, stay connected to new discoveries. Share your thoughts. Have you noticed odd signals or rare events where you live? What do you think lies at the root of these anomalies? Natural fluctuation or something more profound? Stay vigilant, stay curious, and always remember, beneath the stillness of the fields and the certainty of the sky, Earth is alive with processes still waiting, sometimes quietly, sometimes with a shout, to be understood. Let's keep watch together.